Hi, I'm Wessam Hamid, 21 years old from UTM, Malaysia. I'll be talking about GroveBot and GroveFly. Here are the objectives to my project. Mangroves are trees that play an essential role in tackling climate change. They can sequester 5 times more carbon, 100 times faster than most forests worldwide. They are a vital habitat for a vast species of birds, corals, fish, and land animals, including the Bengal tiger. Without the forest, these species would go extinct. Mangrove forests also protect us from tsunamis, storm surges, and erosion. Due to oil spills, shrimp farming businesses, and coastal developments, mangroves are disappearing at an alarming rate. Thailand and India have experienced a loss of more than 85% of their mangroves. These forests can be rehabilitated by implementing community-based hydrologic restoration methods. Sadly, most mangrove restoration projects move straight into planting mangroves instead of conducting sufficient research, resulting in project failures. For successful mangrove restoration, the hydrology patterns, the ecology of the mangrove species, and the factors preventing secondary succession are essential. However, most mangrove restoration projects are conducted without sufficient site assessment and documentation. Therefore, new data will be required to study those factors, which is incredibly time-consuming. GroveBot is an agile, semi-autonomous ground robot in its prototype stage that aims to solve this issue. It uses visual SLAM algorithms to monitor mangrove forests with its track-type navigation system suitable for harsh terrains. It makes sense of its surroundings using camera data through a darknet pre-trained neural network in a 3D LiDAR sensor. It uses sensors to collect environmental data, including carbon monoxide levels, pH levels, and carbon sequestration levels. It comes with 2 arms that work together with its visual odometry to find and collect seedling samples for research. For aerial and ground collaboration, GroveBot pairs up with GroveFly, a working prototype of a drone in the shape of a mangrove blue flycatcher bird. GroveFly consists of an optical flow sensors with forward-facing and a ground-facing camera. The camera feed can be accessed either through a phone app or fed into GroveBot for the ground robot to calculate a programmed goal position. GroveFly helps gather environmental and wildlife information while also actively searching for illegal mangrove tree deforestation operations. Mangrove forests hold substantial economic and ecological importance. They harbor unique biodiversity. Conserving mangroves will help save the planet from increasing environmental pollution. Implementing GroveBot and GroveFly synergistically will help achieve that goal.